Do you mind if I share the slides right quick? I'm worried that they look funny to everyone else. Yeah, how's that looking? Is it looking okay? If I made them squattier, do you think that would be better? Is my face in the way? Those are the kinds of questions I'm wondering about.
I usually run them from the browser and full screen them, but that's about all I do. Otherwise, looks pretty good.
Okay, yeah, because I only have one monitor, so if I full screen it, I can't see the notes.
Ah.
I know. I'm not nerdy enough for two monitors. Sorry, what'd you say?
How do you only have one monitor?
It's really big.
You know,
yeah, it's like 32 inches. And
one thing you can do is you can open it in the browser, clone it, turn presentation mode on the clone, and then only share the browser window that's displaying the full screen one.
Okay.
That's what I've done before on a single monitor.
That sounds excellent. Okay. So I open it in the browser.
Yep. And then hit C to clone.
Right. And then I go back to the browser. I put that in full screen. Mm-hmm. And then I only share the full screen thing. And then I look at the notes on the clone.
In presentation mode. So you hit P after you've cloned it.
Yep.
And then they'll synchronize the two windows.
I have to ask. I know I say this a lot, but has science gone too far? Yeah, that looks good. Wow. Wow, wow, wow. So it's good. Y'all seen any cool movies recently? Well, we have a couple minutes while people trickle in.
I've started rewatching the Avengers movies.
Okay. Yeah, I haven't done that since they've all been out. How is that treating you?
Confusing. I realize that there's like 4 phases of movies and there's like 30 plus movies that Marvel's put out. And so I'm just like years behind. So but good stuff. Very entertaining.
Definitely. Most recent movie I watched was Groundhog Day with Bill Murray.
Ooh,
that's a winner. Yeah, that's a dub. Steve and I watched the Snyder Cut, Ridiculousness. I love the Snyder Cut. I love the idea of the Snyder Cut, maybe more than I like the movie, but it was really tight. I wish more movies, the director was just like, nah. I know that everybody hated this movie, but what if I had the reins? And then puts out a movie that's twice as long and just full of a bunch of like weird CGI.
That's what the Star Wars prequels actually were.
Yeah, I'm trying to think if I've seen any movies. I really watched Napoleon Dynamite yesterday. Holds up. Yeah, I just put it on Hulu, maybe? I don't know. I steal so many accounts from my friends and family that I don't remember where I watch this stuff. Okay, it's been a couple 3 minutes. I feel like it's time to get going. Wow. Okay. What's up, y'all? I'm not Chuck. I'm Breon. And here we are. Intro to R, CSSS508. This is week 3. We're going to be talking about dplyr, which we're going to be using to manipulate and summarize data. And it's going to build, I don't want to say it's foundational, but it's definitely a pillar of what all you're going to be doing throughout the rest of the course and through your R experience if you're a tidyverse legionnaire. I must also say, there's a theme for the week. It's not just dplyr. It's also, wait, did the screen switch? Can you see this?
I can see the share, but it didn't swap to the next window. Is it not synchronized?
It might not be synchronized. I'm sorry.
Might go back and reclone it.
That's exactly what I'm going to do.
I've never had it not synchronized, but it's entirely possible.
Okay, I see. I have it open in like 6 different things. So you're all seeing a black paneled screen with the first slide.
We're actually seeing a big browser window with a...
The black paneled one looks like it's behind the one that we're seeing now.
Even still?
Yeah, it's kind of weird. It's not, it's like it's not sharing the, it's sharing the entire thing, including the small window. Like you got the small window on top of the big one.
I mean, that worked, yeah, but it doesn't. Okay.
It's the technical hiccups that are the most important part of the training process.
It's clear. That's clear to me now. They didn't tell me this while I was training. Black screen.
Black screen.
Notes or no?
I can see the notes.
Okay. I'm going to go back to the other way. And
Yeah, do it the other way. If you had it working before, then just disregard the things that I say.
So I had it where I cloned it, and then I moved it over here, and now over here. And then I shared the one with the browser.
And with regard to the question in chat, what's the difference between quoting or uncoding Gapminder? In library, nothing, because it will load it either way. And you appear to be synchronized, Breon.
Cool.
Yeah, there's no difference between those two, but there is doing like install.packages. But I usually say use them unquoted, but that's just me.
So we'll start again. There's a theme for the week. And you can see how fast I can get into character. It's death to spreadsheets. We're not doing that anymore. We don't need that. We're done with it. All my homies hate spreadsheets. So we're going to talk about dplyr, which does a lot of the same things you've tried to do in Excel, more transparently, more reproducibly, and with some more safety behind it. Don't be the next sad research assistant who makes headlines with an Excel error. Check that link if you'd like. There is a maybe more sad version of what this is that occurred because Excel has a finite amount of rows it can handle, and they lost a bunch of information about. Was it people who had tested positive for COVID in London?
I think so.
Yeah. A shame, really. So we're talking today about modifying data frames with dplyr. If you recall, we've been talking about pipes, and pipes come from the magreader package. dplyr uses the same forward pipe operator, which we've been colloquially referring to as pipes. We can write pipes as the % greater than %. This also can be done with Control-Shift-M, or if you're a Mac user, Command-Shift-M. But operations or operators take arguments on the left and the right side. And so what the pipe does is it takes something from the left side and it puts it as the first argument on the right side. An example would be if we take this object on the left and apply it to the function on the right. So we move x, we pipe it to function y, then it's the same as saying function x in the first argument, y. Throughout the rest of this, and a practice that I think you should get into is talking about pipes as and then. Reading it out loud as and then. I'll give you an example. So we've loaded our dplyr library. We've loaded the gapminder library. Then we say, we have the gapminder data set, and then we filter to values in the country variable that are equivalent to the word Canada. And then we get the first 2 rows of that data frame and spit them out. Cool. Do we have any questions there? We're cool with the pipe. I feel like we've done piping before. Bet. So some of the virtues about the pipe: it saves us a lot of typing. It makes code readable, allowing people to go back through your recipe of whatever data manipulation you've done and say, well, first this research did this, and then they did that, and then they did that, and now we have this output. We'll be using them all the time. The great virtue of them for me is that they can chain together in long lists. So using pipes. Pipes are clearer to read when you have each function on a separate line. That'll be a little bit inconsistent on these slides because we tried to save some space, but most of them are maybe the best practice way of how you would show them. An example, we take these data and then we do the first thing with this value as an argument, and then we do the next thing using that value, and then. So keep in mind the stuff to the left of the pipe gets pushed to the first argument of the function on the right. And I know what you're saying to yourself, but Breon, I don't know which function is going to have data as the first argument or not. I mean, you can be confident that other dplyr verbs that we'll be going over to the rest of today are all going to have data as the first argument of the function. But an example would be if we wanted to run a regular linear regression, data is not the first argument. If you piped the gapminder data to the LM function, it would break. And so the way we get around this is by piping to this dot here. And this dot is, I don't know if I want to call it ancient mathematics, but the reason that you can pipe stuff to the dot is maybe a little bit outside the realm of this class right now. But if you come to office hours tomorrow, I'm happy to talk about it. But like I was saying, maybe it's not clear to you when it's okay to just pipe something to the first argument of a thing. One option you can do is do question mark the function, and the way that the arguments are shown in there are in the correct order. So the first one will show up as dot data, data, something like that, looking for a data frame as your first one. Others, another way you could do it, I'll show you if you don't mind, would be like this. So let's say that we had a function like lm. Do you see my screen for my R screen? Okay. If I hit tab right now, the first argument it'll be looking for is formula. We cool with that? Second argument would be data. And let's see, if we also had, what's another popular one we might use? Filter. Data is our first argument. So that's a good little way, if you're not super familiar with the package, to just check where you can pipe and whether or not you need a dot. Okay. So When we're using pipes, we often want to take all the things that we've been piping and assign it to an object. So when we're creating a new object from the output of piped functions, place the assignment operator at the beginning. And this might be a little bit counterintuitive, but I think the logic of it will make more sense when you think about what it is that you're doing when you want to solve a coding issue. Like ideally speaking, you already know what your endpoint is. And so you can just name your new object what your endpoint is, and then you can use the pipes to create the recipe to get there. So no matter how long the chain is, the assignment is always done at the top. Note, this is just a stylistic convention. If you prefer, you can do assignment at the end of the chain. But I have an analogy for this that I feel like will help motivate not doing that. Over the course of maybe the last year, my spouse and I have gotten really good at baking. And she has a lot more baking skill than I do. So I have to start knowing exactly what pan I'm going to use before I start putting together the dough and putting it in the pan. She does not have to measure things like this and is willing to just say, you know what, this should have more nutmeg. You know what, this needs more salt. And then just pour it in and it will be right every time. And she can use the pan and pick it at the end, but I cannot. I have to pick the pan first, then do the recipe, then assign it to the pan. You feel what I'm saying? Yeah. Okay. We talked a little bit about filtering rows. Recall last week, we used the filter command to subset to data like this. We said, in this pan, in this new object, Canada, give me the gapminder data, and then we'll filter it down to values in the country column that are equal to the word Canada. And then we got this cute little data set. It says, Canada, 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 Canada. The analog to that in Excel would be filter with a capital F. But that only does one thing at a time. We talked about how we could do country equals Canada, or operator country equals United States if we wanted a data frame with both the United States and Canada. Oh, I'm getting questions in the chat. Let's see. Is it possible to filter for more than one thing in the same function? Yes. You could, for instance, say country equals Canada, year equals 1952, and population is greater than 100. And all of that would get you the particular rows. Yeah. For the assignment, I was trying to create filter with 2 countries, but could not figure out the command to use between, I tried % and plus. I think that you're looking for the, yes, I think that you're looking for something like countries, the gapminder data, filter country equals Canada, or country equals United States. And head countries 10. We would have, oh, I guess there's more than that. I'll just look it all up. Canada and the United States would be in that data set. If you used the and operator, it's actually looking for things that are Canada and United States in the same cell, if that makes sense. Is there a shortcut to typing % in % like there is for the pipe operator? Not that I know of. Okay, so another operation that lets us filter things out, but instead of it just being equals Canada or country equals United States, we can save time and create some larger sets. by using the percent and percent. So we can use it like the equals equals, but it matches any element in the vector on the right. So former Yugoslavia will create a vector first using the C function. Remember, this is like combine. It helps us create vectors. And we'll put in Bosnia and Herzegovina, Croatia, Montenegro, Serbia, and Slovenia, all in this vector. I know this isn't all of the Yugoslavian countries or former Yugoslavia countries. These are all the former Yugoslavia countries that are in the Gapminder dataset. And so then we can create a data frame. We have a new object here, Yugoslavia. We assign it the Gapminder data, and then we filter for all of, or any matching element in the country variable that has, that matches with the elements of the vector former Yugoslavia. And as you can see, we can cut down and get our countries Slovenia. Okay, so we have a lot of questions here. Is filter more efficient than something like Canada? Gapminder. More efficient? I don't know. I think Chuck would need to answer that. I'm not sure how much computer time that saves.
Very little.
Yeah, I'm thinking it's negligible. There's few dplyr things that are meaningfully slower than base R operations. Does this also work to create subsets based on values? Yes, you can use filter to do any sort of conditional statement. So for instance, what's going on under the hood of the percent and percent operator is it's saying it's going down the list of everything in the country vector in the country column, and it's trying to match up each of them, and it just presents a true or a false under the hood of all of the things that go on there. So if you can phrase your filter call as like a true or false, it should run fine. I'm trying to think of a counterexample, and I'm struggling to. So what do we use? Filter, they all do the same thing. Okay, so filter is to subset rows. And percent is a way to help us get there by selecting a certain set in a vector. Does that help use?
Oh man, yeah. Thank you.
Yeah, I got you.
Brian, I have a question. Like while doing the assignment, I'm really confused where we are using the double quotations and where we are not using the double quotation. Like when we were selecting, for example, a name of a country, we were doing the double quotes. But I was also feeling that we need to do the double quotation even when we were typing year 1992. So if I'm selecting 1992, that also we need to filter it in put it in the double quotes. Why is that? Can you please explain?
Yes, so the the thing that you're encountering there is that when you're using this filter command, the variable that you're looking for has a type. So it might need you to check if the match is numeric or if it's character in order to match it. I'm trying to think. Maybe. So like when you have something like, let's say that we have a variable called x, okay, and we want to know if x equals 1944. This will give you back a true, but so will x equals 1944. So I'm a little confused about what the situation is on your end.
So the thing that's going on there is a lack of static typing in R is what the programmers call it. So R dynamically is converting X to the same data type as the thing on the right to make the comparison. So in 1944, unquoted is the same as quoted in terms of that comparison. But in other times, you're probably looking at things that can't be converted that way. So if you put just a name without quotes around it, like the country United States, when it's unquoted, it thinks it's an object named United States, like a vector or a data frame, and it doesn't do that sort of dynamic typing with it, because numbers and strings like that, the things that are quoted, are single elements you can run a comparison against, where unquoted names that aren't in like a different color like that are these sorts of objects which R interprets in a different way. You'll get an intuition for it better than you'll get the fundamental nuts and bolts understanding of it.
Okay, thanks.
Cool. So any other questions about percent and percent? We're comfortable with it. I do want to give the caveat that if you are thinking to yourself, how do I do not percent and percent? There isn't one already built into dplyr. But I would also say that maybe think about how to create a vector that will allow you to do percent and percent instead. Okay. So talking about manipulating, modifying data sets. One function available to us, one tool that we have, is the function distinct. It allows you to see all unique values in your data for combinations of columns using distinct. So we could say, we have gapminder, and then distinguish for me all unique combinations of continent and year. And so what it's looking to do is find every unique combination between Asia and the year, or Europe and the year. I don't think there's anything else I would like to know about distinct. Distinct also gets rid of unused variables. So if you'll see in our first example, there's no other data available for us. It doesn't show us the life expectancy. It doesn't show us the population. It doesn't show us the GDP per capita. We could use argument .keepAll equals true, but often this information is mostly meaningless. For instance, like we're just looking for the unique cases of Asia and the year, and it's only looking for, it just grabs the first ones that it encounters in the data set. So we have Afghanistan's information here, but these are sort of non sequitur comparisons that we have. Does that make sense? So I would say .keep_all equals true exists. Stay away from it. One thing that I've been doing a lot recently, as I just got privy to like a restricted data set that has many gigs of size, is sampling the rows that I have in my data frame. So we can filter at random rows within our data set using the sample n or the sample frac commands. For instance, we could take the Yugoslavia data frame that we had created before, and then sample n 6 of the rows, and it just at random grabs 6 of the rows. And we also didn't use replacement. So if we had said replace equals true, we could get 6 of the same row. One other thing that we should note is that we set a seed here. If you use set.seed, it will make all random numbers in a file come up exactly the same each time that you run the file. So this allows you to have a reproducible sample of some large data frame somewhere. You can figure out or go check the help function for set.seed, but I'm not big brain enough to know how to understand it. give it a shot if you'd like. I would also say that one thing that I do like about social science coding is that you get to treat yourself with your solutions to things, the way that you write stuff. And for me, I always set seed, why is 6 afraid of 7? Because 7, 8, 9. And that's just a little treat for me every time I go see some old code and it runs the same. Sorry. That's an exceedingly wholesome and nerdy thing that you can know about me. One thing that we might want to do with a data frame is order the rows in some way related to the values that are within the rows. So we can use the function arrange to sort our rows based on some columns. So we could say we have the Yugoslavia data and then arrange by year and descending population. And if you look at our table here, the year is in order, 1952, 1952, 1957, but it's also in descending order of population. So these are all of our 1952 cases. This is the largest population among those in the 1952 cases. This is the smallest one. Excuse me, I'm sorry. You should note also that it will alphabetize characters, and it will ascend by default. So it does just decide if you put in year that it's going to go from the smallest one to the highest one. And if you want it to go the other direction, you wrap it in this helper function, DESC. Okay. Great. Do you have any questions about arrange? We're cool.
Is there a simple way to prevent it from outputting the sort? The arrange, I should say.
Simple way to prevent outputting the sort.
Like you said, it will always sort of post this, first 10 rows or something. Is there a way to keep it from like if you just wanted to sort it and not actually see any output?
Oh, sure. You would want to assign it to an object.
Oh, okay.
Yeah.
Cool.
Part of the reason that it spits out like that is Chuck likes the code to spit stuff out. He's not a very object-oriented kind of coder. I'm the other way. I assign everything an object and
Does that mean when you do this, like, is the sort of in the background the object Yugoslavia, regardless of whether you output it, is it now sorted? Or does it only do it if you put it into an object?
It only does it if it puts it in the object or in this like little table it spits out right here. You would have to assign it to an object for it to keep that sorting.
Cool. That's really helpful. Thanks.
Mm-hmm. Great. We're going into one of my favorite functions of all time. I use it all day, every day. This is select. We talked a little bit about select before. We used it for our last homework, but let's think a little bit more about it. So we talked about filtering, and that's about dealing with rows. But if we want to include specific columns and put them in the order listed, that's an important part of this. We could say we have the Yugoslavia data, and then we select country, year, and population, and then give me the first 4 rows in the data frame. And as we see, it has now gotten rid of our other variables, and we only have country, year, and population. Seems pretty straightforward. I like it. But what's more is you can actually decide which columns you want to throw out of there. I don't need these anymore. I'm done with them. So we could say Yugoslavia data, and then select, and we'll put a little minus sign, minus continent, minus population, minus life expectancy. And then we look at the first 4 columns of that, and we get country, year, and GDP per capita. I'm trying to think, when I was in your shoes, what would I say after that? But Breon, how could I get rid of some and keep some others? To that, I would say, just get rid of the ones you don't want, and it will keep the ones that you do. But for problems that can't be solved just by the minus, just by selecting them, writing them in piecemeal, there's some helper functions. So some functions that you can put inside of our function select that can help us deal with ever increasingly large amounts of data that we will be dealing with in our particular fields. So select has a variety of helper functions, things like starts underscore with, ends underscore with, and contains. Or you can give it a range of contiguous columns, something like start variable, colon, end variable. So you can see select for details about that. These are really useful when you have a wide data frame. So this will be things like, I'm trying to think of the most. This comes from what's the Detroit youth study?
Denver.
And in it, it tracks what age people are getting married. And so on the side, it says 10, you got married at 10, you got married at 11, you got married at 12, and so on, so on, and so on. And we could just say our Denver Youth Survey, and then select starts with the word married, and it will give us all of the columns with the word married in it. Or we could say Denver Youth Survey, and then select ends with the number 18, and it'll give us just this column here. Neat, right? Exceedingly useful, right? The best information you've ever heard. Okay. There's also where. And where holds a special place in my heart. And especially helpful, useful helper for select is where, which can be used for selecting columns based on functions that check column types. So you can say something like gapminder data, and then select where a column is .numeric. So in all of our columns that are a numeric data type, and then let's look at the first 3 rows of that. And as you can see, we have our year, we have our life expectancy, we have our population, we have our GDP per capita. We don't have country, we don't have continent, because they're not numeric. Those are character information. I will also say it shows this is an integer, this is a double, this is an integer, this is a double. Both integers and doubles are numeric types of data. You can also say gapminder, and then select where is .factor, and then let's look at the first 3 rows. And we have our country and continent. Oh goodness, the chat's popping off. I don't know how Chuck does it. One thing that I find useful about select, but is maybe a scary ledge, is that you can rename columns using select. This also drops everything that isn't mentioned. So use it cautiously, but you can have the Yugoslavia data and then select, and then we say what we want our new column name to be. We'll say life underscore expectancy, it's a lot more legible than life exp, is equal to our old column name. And then give me the first 4 rows of that data set. And what we'll see is that this has changed, and life exp is gone forever. You have renamed this for this instance of the Yugoslavia data. But you wanted to just rename it. You didn't want to select only this column, surely. And for that, we use the function rename. Rename does exactly what it sounds like. It renames variables using the same syntax as select without dropping unmentioned variables. So you could, for instance, say, give me the Yugoslavia data, and then select country, year, and the life expectancy, and then rename life expectancy equals life exp, and then give me the first 4 rows. So we'll retain country and year, and now life expectancy has this far more legible name to boot. Cool. Do we have any questions there about select, rename, overwriting the names of things?
I have a question. I feel like this isn't totally fully formed yet, but if you don't like assign the commands that you do to like a new object, so you're changing like the Yugoslavia like data that you made? Does that make sense?
Yes. So if you don't assign it to the new object, then you are just manipulating it right there. But the Yugoslavia data itself has remained unchanged.
Okay, so it's only within that like chunk of code and that output that it's changed. You didn't change your original data.
Correct.
Okay, thank you.
Mm-hmm. Great. So I want to talk about column naming practices. And I got to tell you, I am egregious with these. My column names are all super long. So let's talk about why I do that and why I think this is good. Okay, so good column names will be self-describing. So don't use inscrutable abbreviations to save typing. RStudio's autocomplete functions take away the pain of long variable names. So you can hit tab while writing the code to autocomplete. Next, valid, so-called naked, column names can contain upper or lowercase letters, numbers, periods, and underscores. They must start with a letter or period and not be a special reserved word. So you can't rename something all caps true. True has an assignment already. Excuse me. Let's see, what else? Names are case sensitive. A capital YEAR is different from underscore, undercase YEAR. Year and year are not the same thing. You can include spaces or use reserved words if you put backticks around the name. Spaces can be worth including when preparing data for a ggplot or a pander or any sort of output thing that you'd like to look nice, since you don't have to rename axes or table headings. Here's an example. Let's say we load the library pander. We have the Yugoslavia data and we filter to just the country Serbia. And then we select year and life expectancy, and then we rename year to a capital year and life expectancy and these little backticks. And now I get to have space in it. And then we can get the first 5 rows, and then we can put it in our pander. And look at how nice this looks, life expectancy. It doesn't just say life exp. But I will caution you that things like renaming for aesthetic reasons, for your plots, for your tables, I put at the end of how we're working on things. Can I give you an example? Can I show you some code real quick? Okay. So let's say we have really long names are type. And we'll give it a number, let's say number 12. Now, if I want to know what 3 times 12 is, I can start typing really, and then just hit tab. And it tells me the exact right answer every time, 36. But if we had something like really long names, assign this 12, and then I went to go type out 3 times really. Chuck, how long has that been in there?
That's pretty recent.
I've never seen this happen. Okay, I'm sorry. I'm a boomer. When you, okay, wait a second. I'm sorry. I was about to tell you the whole wrong thing. The reason that I was against doing this until the end was because you couldn't tab it before in earlier versions of R, but now you can.
There's still another reason not to do it is that there's a lot of R functions that even given the backticked ones will break if they've got spaces in them. It's especially common in statistical operations. So don't use them all the time. But yeah, RStudio lets you tab those now. I only saw that recently myself.
I'm sorry.
Sorry for interrupting, but can you please tell me what does this backtick does? I'm not sure. Like, is it just for giving space? No.
Chuck, can you answer that? I know intuitively what it does, but I don't know like the real reason, if that makes sense.
Yeah, so backticks are kind of interesting. So backticks used for objects like that are essentially what it's saying is that once you put a backtick down, it's saying that literally everything R encounters until the next backtick is treated as a contiguous name of an object. So these things are essentially setting things off. You can write whatever you want inside those backticks, and it's going to pretend it's an okay object name. It's just a way of using invalid object names, basically. So you could put spaces in there and stuff. If you didn't have the backticks there, R would look at that and think that really is an object, long is an object, names is an object, R is an object, and tight is an object. You put the backticks around it, it treats it all like it's one. Does that make sense?
Yep.
Wow. You learn something new every day. All right. That's good column names. Hold on to those virtues tight. They're good. Let's talk about what we really came to do. We came to make new columns. And I got to tell you, the name of the function to create a new column in dplyr is mutate. Sorry. So much stuff on screen. Is mutate. And this might be like an unintuitive name to me and you. We're not weird CS people. Sorry if you're a CS person. But it actually comes from the elder coders who consider manipulating data to be a mutation. But let's talk about how we can make it work in action. I would say when you're thinking about creating something, you're mutating it, mutate, create, you know what I'm saying? Okay, so we have the Yugoslavia data, and then we filtered the country equals Serbia, and then we select year, population, and life expectancy, and then we mutate. We create a new column name. This will be the name of our new column, pop_million, equals our column population divided by 1,000,000. 1 times 10 to the 6. 7? Goodness, I don't do math. We can even just put a comma here and create a second column. Life exp past 40 equals life exp minus 40. And then let's look at the first 5 rows of that. So we have our selected 3 columns, year, pop, and life expectancy. And then we have our population in millions units and our life expectancy past the age 40. It's important that you can create multiple variables in a single mutate call by separating them with commas. In fact, you could reference mutations that we've made prior to this comma in this one. I'll show you an example of that later. Okay. So one common function that we'll use inside of a mutate call is ifelse. We'll be using this in general programming elsewhere as well. This is ifelse, one word. If, then else is something we'll be covering week 7, week 8, something like that. But what ifelse does is it returns a vector of values depending on a logical test. So one sort of like description of how this could work is we have the ifelse function. We have a test that's equal to, does X match Y? If X does match Y, aka yes it does, give me the first value. If X does not match Y, give me the second value. And something also to note is that if NA is either X or Y, it's just going to yell at us and give us an NA as well, because it's a missing thing. It can't be something that we compare to. So an example of this, we make a vector that we're calling example. We assign it these 4 elements, the number 1, the number 0, and NA, which again is a nothing. It's a missing thing, and -2. And if we use if else, our test will be, is example greater than 0? And should example be greater than 0, give me back the word positive. And if it is not, give me back the word not positive. So if we run this 2 lines, we will get this in return. We'll get 1 is greater than 0, positive. Is 0 greater than 0? No, not positive. Is NA greater than 0? It's missing. I don't know. So it's just going to give us back a missing. And then is -2 greater than 0? No, not positive. So this is an extremely powerful tool that we can use for lots of things, but particularly when we're creating rows or creating columns, it can be really useful to us. So here's an example of it to help us create a column. So let's say we have the Yugoslavia data, and then we mutate a new column that we're calling short underscore country is equal to if else, one word, a test, countries equal to Bosnia and Herzegovina, comma, should this test be a yes, give me back Breon's initials, B and H. And if not, give me back as.character country, okay? Then we're going to select just the columns country, short country, year, and population, and then sort them by year and short country, and then give me the first 3 rows of that. And so this is how we're going to be able to show how our new column has handled our if-else statement. Here we have Bosnia and Herzegovina, and in the country column, in the short country column, it is now B and H. So it had tested against this thing, country equals Bosnia and Herzegovina for this row, and received a B and H. And then it did the same thing for the next row, Croatia, but it is not equal to Bosnia and Herzegovina, and so it gave back as.character the same value in country. Yeah, so you can read this for each row. If country equals Bosnia and Herzegovina, make short country equal to B and H. Otherwise, make it equal to the row's value of country. This is a simple way to change some values, but not others. Note, country is actually a factor, so we use as.character to convert to a factor. If you had just left this as country, it would have returned a number, because factors are things that are named numbers, so to speak. Think of it like a Likert scale. 1 is I don't agree. 8 is I really agree. Cool. Do we have any questions there? So Chuck's handling it in the chat. Cool. Okay. recode is another useful function to use inside of mutate. Use recode to change specific values to other values. This is particularly true with factors. You can change multiple values at the same time. Note if a value has spaces in it, you'll need to put backticks. Yeah, so we have the Yugoslavia data. And then, we create a new column that we're calling country. So we're actually just recoding the country variable is equal to recode the column country. When we have a value in the column country that says Bosnia and Herzegovina, give me B and H. And when we have a value in this column that is Montenegro, give me an M. And then show me the distinct countries in the Yugoslavia data set so that we can see how well it went. And B and H is here instead of Bosnia and Herzegovina, and M is here instead of Montenegro. Cool. I generally use this function for this kind of process. The case when, and case when is the dplyr form of recode, kind of. Case when performs multiple if-else operations at the same time. Case when allows you to create a new variable with values based on multiple logical statements. This is useful for making categorical variables or variables with a combination of other variables. Okay, so you might be familiar with this if you are a stata person. This is very similar to generate and replace. So what we're going to be doing is saying we have the gapminder data, and then mutate GDP per capita ordinal, that's our new column name, is equal to case when GDP per capita is less than 700. So for all of the values in GDP per capita column that are less than 700, return the word low. And for all of the values in the GDP per capita column that are greater than or equal to 700 and GDP per capita column that are less than 800, return the word moderate. And then if none of those statements are true, like it's not in the low category or the moderate category, return the word high. So this is for when a value of all other statements are false. And then slice, which just lets us grab some of the rows. This is actually row 6 between 9. Let's see what it looks like. So here we have Afghanistan in 1977, and its GDP per capita was 786, which would put it squarely between greater than or equal to 700 and less than 800. Whereas it in 1982, the GDP per capita was 978, which doesn't meet the requirements for either one of these two logical expressions, and so it gets a high, and so on and so on.
So what is the function of true here? I'm not getting how true works here.
Sure. So true here is saying that if the value in the column is false for the other logical expressions, return to me this value. Does that make sense? So for all the things that have been said.
Mm-hmm.
How to use tilde again? For missing, set is not an A thing. Okay, I feel like Chuck's handling the chat pretty good.
I can make a comment on tildes. So tildes always signify an R of formula, which is sort of an odd type of object. And this is basically just saying, this is a formula where the thing on the left produces the thing on the right. And so when this condition on the left side of the tilde is satisfied, it yields the thing on the right. It's just an odd sort of syntax specific to case when to make it easy to use, but it's quite specific to case when. The tilde just means if the thing on the left happens, I'll return the thing on the right.
Thanks, Chuck.
Could I ask a quick question about recode?
Yeah.
If you go back to this code, I just noticed that for Bosnia and Herzegovina, there was sort of these, I don't know, they're not quotes, I don't know what to call those, but for Montenegro, there was nothing around them.
Yes.
What distinguishes those two arguments?
Okay, so the reason that we have backticks here is because there's spaces in this word. And so it's looking for, so like so backticks are letting you know, or letting R know that this is like something that's breaking the rules of naming, but Montenegro is not, so it's just the one word.
Cool, thank you.
Mm-hmm. Okay, we have the pull function. Here, sometimes you want to extract a single column from a data frame as a vector, or perhaps a single value. Pull will pull a column of a data frame out as a vector. So if we say gapminder and then pull the life expectancy column, and then the first 4 rows of it, it will actually pull out as a vector with 4 elements. And this can be contrasted by if we said gapminder and then select the life expectancy column, and then the first 4 rows of that, and we'll actually get a table that is 4 rows by 1 column with the same information in it. This is something that I would say I rarely use, but when I need to use it, it's important. When I need it, it's like a big deal. So here's like a useful example of how we would use pull. So pull is particularly useful when you want to use a vector-only command in a dplyr chain of functions, say in an inline expression. So in this inline code, the average life expectancy in Afghanistan from 1952 to 2007 was backtick R gapminder, and then filter to the country Afghanistan, and then pull. So we're going to make a vector of the life expectancy column, and then give me the average of the elements in that vector, and then round it to 1 decimal place. Years. So we'll actually produce this output, this sentence here. The average life expectancy in Afghanistan from 1952 to 2007 was 37.5 years. So the function mean can only take a vector input, not a data frame. So this won't work if you said select life exp instead of pull life exp. Okay. Now we're going to get into summarization. Summarizing is an incredibly important thing in all of our social science needs. So put your thinking cap on. Okay, so if we generally want to aggregate things, we're going to use the word summarize. I will also note you can spell it with S. Sometimes when you have an error with your summarize, your scouring Stack Overflow, maybe spell it with S also, and that can help send you where you need to go. But summarize takes your columns of data, computes something for every row. So you could say, count how many rows there are, calculate the mean of everything here, compute the sum of all of these rows, obtain a minimum or maximum value among all of these rows. You can use any function in summarize that aggregates multiple values into a single value. Okay, I'm going to say that again. You can use any function in summarize that aggregates multiple values into a single value. So things like getting the standard deviation, getting the mean, getting the maximum value in a multiple values set. So here's an example. For the year 1982, let's get the number of observations, total population, mean life expectancy, and range of life expectancy for former Yugoslavian countries. So we have the Yugoslavia data, and then we filter to the year 1982, and then summarize And after summarize, we're going to name a new column. We're going to say n_obs. It's equal to n, the function. This will tell us how many rows there are. Total pop, which is equal to the sum of the population for all the rows in 1982. The mean life expectancy is equal to mean life exp. And the range of life expectancy is equal to the max life expectancy minus the minimum life expectancy. And what this will return is a table with 1 row in it and 4 columns. And those columns will be the number of observations that we had for the year 1982 in the Yugoslavia data, 5. Total population looks like 20 million some. The mean life expectancy is 71, and the range of life expectancy 3.94. Yeah. Do you have any questions there about this? We're about to do some more thinking about summarize, but before we get too in the weeds. Cool. Okay, so one of the beauties of summarize is that it also comes with a bunch of helper functions that help us avoid repetition. So maybe you need to calculate the mean and standard deviation for a bunch of columns, for a gang of columns. With the across helper function, you can put the variables to compute over the first using like C to make a vector or select syntax, and put the function to use in a list after. So here's an example. We have the Yugoslavia data, and then again, we filter down to just 1982, the year. And then we summarize across, and we're going to summarize across a vector of 2 of our columns. It's going to be our life expectancy column and our population column. And then we're going to, within that column, make a list using the function list, where it's average equals tilde mean. Again, there's that dot to say means looking for this here or this here. And standard deviation equals tilde standard deviation dot. So what we'll get is a table with 1 row, 4 columns that tells us the average life expectancy is 71.3. The standard deviation of this distribution here is 1.6, and it does the same thing for our population. When I first saw this, I was like, that's a lot. That's a lot of stuff. It's strong. It does things. Do you have any questions?
Can I ask a quick question here? So I've been struggling here with like filter. So, you know, I was messing around trying to filter instead of years, like do countries, or instead of, you know, even trying to do columns. But I just filtered by Serbia, which is part of the Yugoslavia data, right? And
Sure.
like it yielded like no results. And I'm just wondering, I guess the question is like when you're filtering from like a data set like Gapminder, are there some like things to keep in mind there?
I don't know. I would have to look at the code, because I suspect that if the filtering is yielding nothing, that perhaps the conditional statement is looking for a column that's maybe not there. Might have gotten deselected somewhere.
Yeah, when you get stuff like that, check it into the like the Slack channel. Or email list will take a look and let you know pretty fast.
For sure. Okay. So, like I was saying, it's a lot to look at. One way that you can sort of deal with that is by spacing things out. You know, get hard to read code with a lot of nested functions, which is one of the virtues of dplyr, is not having a bunch of nested functions. But then here we go with a bunch of nested functions. So we can break things up by saying summarize, and then we just hit enter, and then across, and then hit enter. And then we're here looking at everything separately, and it's way easier to look at. In fact, one other option I would say, I could just switch to here. Is that if I click here, it actually highlights down here where my parentheses is, and this helps me keep track of them a lot easier. But one thing also is, this is pretty recent to R, is that you can have it color your parentheses, so it will help you keep track of them by color as well. And the way you do that is by going to global options, and I think appearance, code. You go to code and then display, and then there's a little checkbox here that says rainbow parentheses. Really useful. Okay, so like I said, we're trying to avoid repetition. There are additional ways to use across for repetitive operations. So we could say across everything its own function. And that will summarize and mutate all variables sent to it in the same way. For instance, getting the mean and standard deviation of an entire data frame. So we could say for some data frame, and then summarize across everything the same thing. List mean equals tilde mean, and standard deviation equals tilde standard deviation. And it will compute it for every variable that we give it. We could also bring back where, shoutouts where. Across where will summarize and mutate all variables that satisfy some logical condition. So let's say we have some factor here, so we can't just use everything and compute a mean over something that has no inherent numeric value. So we could instead say summarize across where is dot numeric, and list and do this. This will help us let the computer handle doing a bunch of repeated typing instead of us. Cool. So here's a function that I use basically every day. I see it all the time. It's my best friend. It's group by. And if you're into, what's the name of that? SQL, I'm sure you've seen group by a trillion times. Group by is a special function that changes how functions operate on the data. Most important case would probably be summarize. So functions after group by are computed within each group. Okay, so you specify to it some group, and that's defined by variables that you give it, and it does the function operates over the group instead of all of the rows at once. Typically, the variables you give it will be things like integers, factors, or characters, not continuous or real values. I'm sure we can get behind that. The analog in Excel would be pivot tables. I feel like they're always talking about that on LinkedIn. You know, do pivot tables. Okay, so one example we have is we have the Yugoslavia data, and then we group by the year, and then we summarize the number of countries equals n underscore distinct, which just gives us the number of distinct rows in this. It aggregates the number of, I feel like I'm saying a bunch of the same words again. It aggregates the number of values that are the same within a column. We also get total pop, which is equal to the sum of population. And then we also have total GDP per capita, which is the sum of the population times the GDP per capita, and it's divided by the total pop. This is the example that I said we're going to see before. Total pop is created right here, and then you can immediately use it to do other calculations right here. That's really useful. It's nifty. Okay, so like I said, we grouped by year. We summarized to create these three aggregated things. So now we know that in 1952, we had 5 countries come from our data set that have that. The total population for all of the former Yugoslavia countries there was this big chunker, and the total GDP per capita was 3030. Because we did group by with year, then use summarize, we get 1 row per value of year. So we've now made our unit of measurement the year. Our rows are now by year instead of per country year. So cool. Okay. Next, we're going to talk about some window functions. So if we grouping can also be used with mutate or filter to give rank orders within a group. Something like lagged values or cumulative sums can be calculated per group. You can read more about that in this vignette. Highly recommend. I didn't know that there was all these different kinds of things. I only knew maybe, I don't know, half of those. It would have been a lot more useful when I was taking demographic methods last quarter. I'll tell you that much. So I had the Yugoslavia data, and then we select the country, year, and population, and then we filter to just the rows that where the year is greater than or equal to 2002. And then we group by the country. Okay, so talking about group by the country. And then we mutate a new variable called lag population, which is equal to lag pop order by equals year. So what's going on here is it's looking to the previous column in the data, or the previous row in the data set and showing me the population. And it's actually ordered by a different variable year. And then we're also going to get the population change, which is equal to our current population minus the previous population in the data set. Keep in mind, we're grouped by the country. So for instance, we have Bosnia and Herzegovina. In 2007, we see that our population is 455,000 people. And our lag population is equal to the 2002 population. But since there isn't a earlier row than 2002, our lag population for our 2002 row doesn't exist. It's missing. I feel like that blew my mind the first time I saw it. So I want to give you a second. Do we have any questions about how lag works and how it stayed within the group? Because it doesn't check. For instance, Croatia could have looked in the previous column for population here had we not grouped by the country, but it didn't since we did. Brilliant. Yeah, it's tight. Okay. Whew. Speaking of SQL, we're talking about joining and merging data frames. This is a big deal. I feel like I do this nonstop as well. Group by, select, merging, joining. So when do we need to join tables? You want to make let's say we want to make a column using criteria that's too complicated for if else or case when. I know that you just got maybe familiarized with if else and case when, and the possibilities seem endless. They do end, and things do get more complicated. And sometimes you're going to want to work with a small set of variables and then combine them back together to rejoin your data set later. Another example might be, we want to combine data that's stored in separate data sets. So I know that Chuck was privy to combining registrar data with police stop records. That's really tight. That's not something that they would have me do. Instead, what they would have me do, for instance. So I'm working on this project that's, it's looking at like the lifespan of businesses across different like gentrification contexts. And what I have is like a really thick and rich set of information about the businesses. And I geocoded it, which we'll talk about eventually, and have like census tract information about the businesses. But I don't know anything about the census tracts. The business data doesn't tell me anything about the census tracts. So what I did was I downloaded a bunch of census tract information And then I'm going to join it back onto my business data set so I can do some cool maths, talk about the not so fun things that sociologists get to talk about. So often large surveys are broken into different data sets for each level, the household, the individual, the neighborhood. Yeah, I experienced that recently with this like union dues data is down to the union level, but also the business and also the state. And you can combine them all using the tools we're about to talk about. So let's talk about joining as a concept, as an idea, as a theoretical thing you could be thinking about. So we need to think about the following when we want to merge a data frame we'll call A and a data frame we'll call B. So these are the three questions you're going to want to answer every time you're going to do a join. Which rows are we keeping from each data frame? So which rows from data frame A, which rows from data frame B do we want to keep in our new joined data frame? Which columns are we keeping from each data frame? So among A and B, which columns are still useful to us in our new joined data set? And which variables determine whether rows will match? And this is a big question about how we're going to combine these two things that perhaps weren't designed to talk to each other. We'll see. So there's going to be a lot of information on this slide. Be cool. We're going to talk about it. So there are many types of joins. Yeah, here it says usually left join will do the job. That's true. I think that left join will get most of the work done for you. But I'm also an English user, so left join makes sense in my brain that we have a left thing and then we throw it on the side. So we'll talk about it. So keeping in mind we have a data set A and a data frame B. Let's say we have A and then we left join B. What this would mean is we keep all of the rows from data frame A that are matched with B wherever possible. And if it's not possible, they're going to feed us an NA. But we're going to keep the columns from both A and B. So already, this is a really powerful tool on its own. Whereas we could right join things, which will say A, we have our data frame A, and then we right join B. We keep all the rows from B that are matched with A wherever possible, and A would not, and keep columns from both A and B. Excuse me. We have inner join. Is inner join the one that's likely to go Cartesian? No.
No, full join.
Full join. Yeah. Okay, yeah. I'll talk about that in a second. So we have data frame A, and then we inner join with B, where we keep only rows from A and B that match. So this keeps columns from both A and B, but it also squeezes the amount of data that we have probably. Here's the one that has crashed my computer a bunch of times. So I just want to say with the caveat that it's okay that happens. It happens to everybody. Well, maybe not everybody. I'm sure there's somebody out there who just, I understand this immediately, but I did not. So A, we have data frame A, and then we full join B. We keep all the rows from A and B matched wherever possible and keep columns from both A and B. Okay, so let's say we want to keep all rows from both A and B matched wherever possible. If you matched on, let's say, like all of the columns in your data set, you might run the risk of exponentially increasing the size of your data set based on the total amount of rows that you have. And that can happen and then eat up all of your, what's that Daft Punk album? Random access memory. It can take all of your RAM and that will crash your computer. It's okay, but I'm sure we'll get a couple of those emails this week. We could have A and then semi-join B. We keep rows from A that match rows in B, keeping only the columns from A. I'd say this one's not super popular. Semi-join and anti-join kind of function as like a filtering kind of mechanism more than they function as like a combining two data sets kind of mechanism. We could have data frame A and then anti-join B, where we keep rows from A that don't match rows in B. I know that's a lot. I know I said a lot of things. I know I said A and B 4,000 times, and it's looking like a lot, but don't memorize this. Just come back and look at the slide. Just look it up every time. That's what I do, and it treats me great. I'll also say left join does the job most of the time. Can you explain NA when not? Sure. So let's say that we have our Gapminder data, and we've already filtered to just Canada. Okay. So we have, actually, no. Let's say we have the Gapminder data, full stop. But we also have data on countries that do really well in the Winter Olympics. And we want to match them based on the country. We could expect that they will match on like Canada. We can expect that they'll match on like Russia or Norway, where skiing is tight. But it won't match on Costa Rica, where skiing's not that popular. And where it doesn't match, it'll just give an NA. So where it says Costa Rica, it will provide an NA there. Okay, I feel like we're handling questions. Cool. Okay, so we have some matching criteria. We say rows should match because they have some columns containing the same value, okay? So among our two data sets, they have some rows that have the same value, like an identical value. Our matching behavior, by match using variables A and B that have identical names. Okay. So we could say in our join call, by a vector of columns. For instance, variable 1, variable 2, variable 3, which would be found in both data sets A and B. But we could also, let's say, not have the exact same name for the columns in both data frame A and B. We could specify to our join call that we want to do by equals and make a vector where this variable 1 in our data frame A is equal to variable 1 in data frame B, but they might have slightly different names. So like I said, I was joining data sets by state and business, and some places do state, or I had column names that were like state underscore name, and then a column name that was like state underscore abbreviation, but both of them just had the regular abbreviations for United States states. So I made a call like this, but I am more likely to just rename my columns to be the same thing in both the data sets, should time allow. Note, if there are multiple matches, you'll get one row for each possible combination, except for when you use semi-join and anti-join. This is typically what you want to happen, in that it will increase the size of your data frames in total rows, but it is something to be aware of. If it needs to get more complicated, break it into multiple operations. That's something that I would do. Definitely multiple, like left join to this, make a new thing, left join to that, make a new thing, left join to that, and so on. Okay, are we cool with matching criteria, or am I just saying a bunch of stuff out loud? Okay, Sean gave me the double thumbs up. That's really good. That will get me into a movie. Okay, so let's talk about the data that we're going to be using for the homework. We have the NYC Flights 13 data. We're going to install it and load it like this. Install.packages, uncomment to run. You can throw this in your console. I do not recommend throwing it in your code, as always. And then if we load the library NYC flights 13, we'll see that it actually has 5 data frames combined or found in it. Some of which contain missing data, which if you're on the Slack, you know some people have already encountered. But the 5 data frames are thus. Flights is flights that are leaving JFK, LGA, and EWR in 2013. I think these are all 3 New York area airports. I've only been in New York once. I'm a Southern boy. I don't know nothing about no New York. There is the airlines data set, which has the airline abbreviations. There's the airports, which is a bunch of information about the specific places that planes land and so on. There's the planes data itself, about which planes are taken off when and what they are and what the name of them are. And then there's the weather, which will tell you the hourly weather data for JFK, LGA, and EWR. Note that these are all separate data frames, each needing to be loaded separately. So you'll have to do data flights or data airlines or data airports in order to create that promise and put it in your environment. So next I'm going to go through a few examples of how you can join these things together so you can sort of get your mind working on Elmer and joins in general. Okay, so let's say we have our flights data frame, and then we filter to the destination Seattle. That's where I am right now, big shouts. And then we select the tail number, which is like the exact plane. And then we left join that information. So this thing that we've produced, we left join that to the planes data, which we have also manipulated by saying, and then select the tail number and the manufacturer. Little thing to note here, dplyr will handle inline manipulations of other data frames. I think that stresses me out. I'm not so good at writing code that does this. I am privy to dechunking it and making multiple left joins if I need to, but it will handle this should your brain feel comfortable doing that. Mine does not. And then we say left join by the column, which is in both tail num here and tail num here. So by tail num. And then we're going to count the manufacturer, and then we're going to arrange it in descending order. Okay, count is a really strong function on its own. It summarizes data by taking all of the unique values in the column that you feed it and counting the number of rows that are at each value. Okay, so it counts observations by manufacturer, and then we're going to arrange it in descending order. It also just names the variable that it creates n. So that's why this is in descending order n. So that will produce this table, which has got 6 rows and 2 columns, where the manufacturer, so these are each of the distinct manufacturers in our data set. One of them is NA. And then how many of the flights to Seattle were by that manufacturer. Note you can perform operations on data inside functions such as left join, and the output will be used by the function. Operations on the data inside. Okay, yeah. Great. Here's another example. Which airlines had the most flights to Seattle from New York City? So I would also say that this kind of question making makes it a lot easier to code things. When you have a very specific yes or no kind of answer that you're looking for, it'll make it a lot easier to do the homework also. So we have the flights data, and then we filter again to Seattle, go storm, and then we select the carrier, and then we left join to the airlines data frame by the carrier. And then we group by the name, which is just the name of the carrier, right? It's the name of the airline. This is going to be like Delta, American, JetBlue, Spirit, Southwest, what have you. And then we're going to tally it and then arrange in by descending order again. So something I should note is that count does the exact same thing that group by name and then tally does. It is doing the same thing under the hood. It is grouping by this variable and then telling me how many observations are at each value of that variable. Okay. This is just another way to get that same kind of answer. So you could, at this stage, do count, name, and then arrange, and it would work the same way. Yeah, here's a little note on it. Tally is a shortcut to summarize and increase a variable n equal to number of rows in each group. Yeah, there's yet another even more long-winded way to do it that Chuck is alluding to here. But it gets us at the same answer. Okay, and then our last one is, I don't know, great. Is there a relationship between departure delays and wind gusts? That's a good question. I think that's a really great question to try to model. So why not model it with a graph? So first we're going to load library ggplot2, which we got some practice in last week. We'll use the flights data, and then we'll select the city of origin, the year, the month, the day, the hour, the delay in minutes maybe of the departure. And something to note, year is actually extra here. All of the data is from 2013. And you interjoin it with the weather data frame by origin, year, month, day, hour. Because the weather is hourly updates at our origin airports. And then we select just the departure delays and the wind gusts, the departure delays which come from our flights data and the wind gusts which come from our weather data. And then, and this is important, I see a lot of people talking questions about this, removing rows with missing values. So then we filter for anything that's not an NA in departure delays, anything that's not an NA in the wind gust columns. So what's going on here is that is.na function tells you simply if something is missing or not, and provides a bunch of trues and a bunch of falses for something is an NA. So what it's saying is there NAs in the departure delay? If it is an NA, feed me a true. But this question mark operator, exclamation point, is saying flip the true and falses here. So it's saying that if it's an NA, give me a false. And so our filter is looking for all the true things, which are things that are not NAs. This is a nifty little thing. I use this all the time. And then we're going to put it into a ggplot where our mapping aesthetics are X is the wind gust, Y is the departure delays. We're going to put points for each of our observations, and then we're going to put a smoother through it. Yeah, and keep in mind, because data is the first argument of ggplot, we can just pipe straight into the plot, which is super useful for doing things like rename that we talked about earlier, where you could just, you've massaged a data set enough, and then we rename the things right before we throw it in a ggplot, and it makes it really nice. Oh no. Okay, so check out these 1,200-mile-an-hour winds over here. That's astronauts only over here. These observations have been fixed in the current data. These are some outliers over here, if you can't tell. But we run it again after removing those extreme outliers, which were not supposed to be there. So So the way that we decided to, Chuck decided to get rid of the outliers is to just say filter and wind gust is less than 250 miles an hour, which is, you know, earthly. And then add some things like theme black and white, base size of the font, some X labels that are readable, some Y labels that are readable. Remove the geom point to focus on the mean trend produced by geom smooth. I like that. I like an average. And look at that. Look at how much more average departure delay we get as the wind gusts go up. I'm interested in what's going on at down here. I guess this is just the middle of it, but here's some suggestions. Looking forward to our homework. Some possible questions to investigate. What are the names of the most common destination airports? So that are receiving the most traffic. Which airlines fly from New York City to your home city? Because I tell you, I'm from Atlanta. We fly everywhere, you know what I'm saying? Is there a relationship between departure delays and precipitation? I feel like we have a pretty solid setup before about how to get weather to combine with departure delays. What is the distribution of departure times from flights leaving New York City over a 24-hour period? Quite a question. Are especially late or early arrivals departures to some regions or for some airlines? Yeah, I bet you could even like tell what gusts are good and go in this direction. Warning, flights has 336,776 rows. So if you do a sloppy join, which I know I would, I know I did, you can end up with many matches per observation and have the data explode in size. Not to worry, turn off your machine, go back, and before you run it again, look at how your joins are working together. Maybe look at a sample N or a sample frac to think about how you're going to join. Okay, so for homework 3, you're going to pick something to look at in the NYC Flights 13 data. Write up an RMD file about it, showing your investigation. Going to upload it to Canvas as we've been doing. You have to use at least one mutate, summarize, group by, and any of the joins. There was like 7, 8 of them, any of those. Include at least one nicely formatted plot from ggplot2 and one table using Pander. And plots and tables. Use nice variable names. Try out the spaces. See how you feel about backticks, when you're going to want to use backticks, how much writing that is. Now that you can just tab over, I'm like, I'll use backticks way more often. And rounded values less than or equal to 3 digits. This time, this is important, include all your code in the document. Use echo equals true. Using comments and line breaks, separating commands, so that's easier and clearer for your peers to see what you're doing or we're trying to do, you know, no worries. This is a learning environment. Well, you must write up your observations briefly in words as well. So just, you know, this is what this is doing. This is what this looks like. For me, I'm thinking this, and so on. Note, if you want to see the NYC Flights 13 data frames in the environment, you will need to load each one. So that's that. That's dplyr, more or less. Do we have any questions? Do you have a way to check for duplicates before merging? I don't know. I don't know if I do. I feel like I just have a intuition about when my data sets are going to explode now that I've messed it up enough. Chuck, do you?
Yeah, so it depends what kind of duplicates you mean. If you mean duplicates in the sense that like you have IDs in data frame, like your left side data frame, and that when joined to the right side data frame, there's going to be multiple like joins. If you're thinking duplicates in that sense, the way to actually do that, there's a couple different ways you can do that. You could use things like anti-joins and semi-joins to detect how many matches and non-matches there are. You can actually perform the join and just see if the data frame size changes. Or you could count the number of that you could literally count the number of matched IDs between the two data frames. So you could pull like the ID column or columns from the first data frame, just the IDs, and match them to the other one, including using just like logical statements. There's like a dozen different ways to do this depending on it. And it's not too important how you do it unless your data are relatively large. If you're working with large data frames, I mean, you've got a couple 100 million rows on each side or something like that, you want to do these checks by like extracting a vector and matching them side to side and counting them in a tabulation. I can show in lab like how to do that kind of thing. But normally your data frames are small enough your computer can handle it. I mean, your computer probably doesn't care if there's a billion rows. It might take a second to do it, but it's probably not going to crash your machine. Yeah, that's exactly there what John's saying there too. You can use distinct on the IDs and compare the number of observations against the ones in the data set. If they're the same, you're good. It gets a little iffy when you have when you know you're going to have partial joins from both of the data sets on both sides. And also things like when there's like repeated observations, different types. Like, if you've got different repeated observations across the data frames, you don't know what your result's going to look like until you kind of do it. But usually you don't really have to worry about destroying anything. Even if you manage to fill up your computer's RAM, you don't really lose anything. You should be fine. Nothing else? Okay. See you folks. See you on Monday for our next lab. Assuming there's not a sneaky holiday or something I forgot about. Got a question on lags. What we got?
When's Earth Day? Sorry, what?
Yeah. Thanks. This was super helpful. I am pretty new to R and don't think I fully grasped the power of that lag example you were showing. Do you mind walking through that one more time? I think we were looking at Yugoslavia and you were using mutate for lag population. Do you mind just running through that one more time? Yeah.
So what's going on here is that we've selected down to country, year, and population, and we only have the cases that are greater than or equal to 2002. So there's only 2002 and 2007 in the data set. So that's like a good place to start, is just to know that there's only going to be 2 rows per country.
Right.
We group by the country, and then we make a variable that is called the lag population. There's a function is it in dplyr or is it in tidyr?
dplyr.
Like it's in dplyr. Called lag, that just looks at the previous row.
Okay.
And in the particular column that you're asking for, and puts it where you ask it to go.
Interesting.
This argument here is just saying, look at the previous row by the year. It's not looking for previous row by some other check. So this is like an important redundant thing to make sure that it's checking the right place.
Okay.
In the case that this data set got dearranged in some way.
Got you.
Cool. But yeah, it just looks in the previous row. And then, so like this value is the same as the population in the previous row.
Okay.
And this value is the same as the population in the previous
Got
row.
it. Very cool. Okay. Yeah. No, that's super helpful. Thanks. Appreciate it. That was really awesome. Great job. Thanks.
Okay, I'll kill the recording here. Stop recording.